In this video, we will use number 20 as our first example, and we are to describe how to transform the graph of f of x equals x squared into the graph of h of x equals 1/4 x squared minus 1, and then graph h of x. Well, what you see here is that what you're really looking at is what's in h of x that's not in the parent. And so you have to account for each thing that's there that was not in the parent and what that effect would be on the graph. And then we're going to use those notes we make to graph the function. Again, this is a no calculator problem, so we notice that 1/4 is the first thing we see that's not in the parent. So we're going to jot that down, and however you want to, you can denote that we're talking about the 1/4 here, and the 1/4 gives us a vertical, and we know that the change is vertical because the 1/4 is outside the square. So it's a vertical shrink of 1/4. And then the only other thing we see that's not in the parent is the minus 1. And again, it's outside, so this will be a vertical translation down 1. And we know it's down because it's direct, because it's outside. So we are going to come over to our graph space, and we're going to graph the function using function transformations. And so the parent graph would start at the origin, but this one has a vertical translation down of 1, so we plot our vertex there. And then for the parent, we would go to the right 1 and up 1, but because of that vertical shrink by 1/4, we're going to go to the right 1 and up 1/4, and then mirror that move on the opposite side of the vertex. Then we're going to go to the right 2, and for the parent, we would go up 4, but we're going to go up 1/4 of that, so we're going to go to the right 2 and up 1, and mirror that move on the other side. And then we're going to go to the right 3, and on the parent, we would go up 9, but now we're going to go up 1/4 of that, so 9 over 4 would be 2 1/4, so I'm going to go to the right 3 and up 2 1/4, which would put me about there, and I mirror that move on the opposite side. Then I go to the right 4, where I would normally go up 16. I'm going to go up 1/4 of that, so I'm going to go to the right 4 and up 4, which puts me here. Mirror that move on the opposite side. And then I'm going to go to the right 5, which would normally, on the parent, I would go up 25, but I'm going to go up 1/4 of that, so that would be 6 1/4. And that puts me there. Mirror that move on the opposite side. And then I can draw my parabola by tracing through, oops, that's terrible, the points that I just plotted. And this is what my parabola looks like. On 26, super simple little transition problem into the next set. We are to find the vertex and axis of the graph of g of x equals 2 times x minus the square root of 3 squared plus 4. So since it's already in vertex form, I get the vertex for free. So the vertex is at the square root of 3, 4. And the cool thing is that you get the axis directly from the vertex. So the axis, otherwise known in Algebra 2 and 1 as the axis of symmetry, the axis is x equals whatever the x is in your vertex, so it's x equals the absolute value of 3. And that's number 26. So then on 28, and I put an asterisk on these directions because I'm going to have you approach these slightly differently. Now, if you're a glutton for punishment, do the directions as they're written, in the order they're written in the book, and you will understand that the authors are basically trying to show you how torturous it is if you don't complete the square first. But I'm going to trust that you'll take my word for that and just do it the way I'm going to do it here. So we're going to rewrite in vertex form by completing the square and then state the vertex and axis of this graph. So we begin our completion of the square by pulling out any coefficient on x squared from both of the x terms. which gives us x squared minus 7 over 2x. Leave a space for our completing of the square, and then pull the minus 3 outside. Let me squeeze that in a little bit so I'll have room to write what we're going to add here. And remember, once you write that in, you need to go inside, and this is always a plus. You take half of the middle coefficient, which in this case would give us 7/4 squared. And so since we just added 7/4 on the inside, that's being multiplied by -2, we really just subtracted 2 times this number. So we're going to add 2 times the number to make up for it. So let's see if I can squeeze this in. Alright, and then that becomes -2 times x minus 7/4 squared, and then minus 3 plus 2 times 7/4 squared. We'll come over here to the side and do that. So we've got 2 over 1 times, and if I have 7 over 4 squared, that would be 49 over 16. And then the 2 cancels off and makes the 16 an 8. So that would be 49 eighths. And then 3 minus that, I want to rewrite 3 in terms of eighths. So that would be -3 over 24. No, I'm sorry, rewind, try that again. I'm rewriting this so that its denominator is, what is wrong with me? is 8. And so that means my numerator is going to be 24. That's the 24 I kept trying to write in the bottom. -24 over 8 is, and the way you can double check that is divide it. -24 over 8, yep, that's -3, I'm good. So then we're going to add to that, and remember this fraction was our 2 times 7/4 squared, so, and then reduced. So this is 49 eighths, and then 49 eighths minus 24 eighths, which is in essence what we're doing here, is plus 25 eighths. So now we can see our vertex, which is 7/4, and our y-coordinate is 25 eighths. And the axis is x equals 7/4. And that is number 28. So then we move on to number 34, our next example. And in this set, the authors are recommending that you do what we just did. So we're going to go ahead and keep practicing what we just did on this problem. So we're going to complete the square, but now we're not going to name the vertex and axis. We're just going to describe the graph using our function transformation way of looking at things. So this is an easier completing the square problem. And there's nothing to take out of our x terms, so we can just put parentheses there. In fact, let me back up and move right a little closer to the center of the screen to have room to show all this. So g of x is x squared minus 6x, and leave space to put your third term, and then slide the plus 12 down out of the way. And then remember, on the inside we're going to add half the middle coefficient squared, but there's nothing in front multiplying this, so I really just added 9, so I'm really just going to subtract 9 over here. And we get x minus 3 squared plus 3. Okay, and remember, all we want this for is to describe, if I can talk, what this graph would look like. And let's just call it f of x equals x squared translated right 3 and up 3. And that's a completely adequate description of this graph, because if we took the parent graph and translated it right 3 and up 3, we would get the graph they gave us. So we don't need to say any more than that. So let's look at 42. This one you're given a picture of a parabola with a couple of points highlighted, and one of them is the vertex. We're to write an equation for the parabola And again, this is a calculator problem, but there's really no need for a calculator, so let's look at it without the calculator. We're going to write the equation using the fact that one of these is the vertex. Well, the smart way to proceed here is to start with writing the vertex form on your paper. Kind of like when we were doing word problems the other day at the end of chapter 1, and we wrote the geometric formula that was implied by the problem. And while I'm talking, I definitely just put a plus where I should have a minus. So let's fix that. Alright, now I got it right. Okay, so it may be helpful to you if you will, and since obviously you're not going to have this on the ones you do for homework, you're not going to have the picture to write on, but on the picture here, let's go ahead and label our vertex HK so that it'll match the vertex form, and then whatever other point we use is XY. So now I can just look back at the picture if I need to write this equation in the order that vertex form requires. So I want y, which in our problem is negative 13. We don't know a. That's what you're going to be solving for in this step. Our x is 2. Our h was negative 1, so that's minus negative 1 or plus 1 on the inside. And then our k is the y-coordinate of our vertex, which is plus 5. So the first step, we would subtract 5 from both sides and get negative 18 equals a times, and 2 plus 1 is 3 squared is 9. So then we can divide both sides by 9 to get our a, which is obviously negative 2. And so our vertex form equation is y equals negative 2 times x plus 1 squared plus 5. Now that was the analytic way to do this problem. And the reason that I centered the picture on this screen is that we're going to go back and look at this from a graphical perspective, because you can do what I'm about to show you, but you've got to be able to put enough down on the paper that it's clear that you know what you're doing. So just drawing a little ugly graph and then scribbling and making some little arrows is not adequate. You've got to articulate what you just did. So to start, I'm going to erase the notations we made for our analytic analysis of the picture, and I'm going to use some other things to mark to think of it graphically. All right, well, clearly we know that the vertex is negative 1, 5. So for a minute it's going to look like I'm doing the same thing I just did, but I promise you this is different. All right, so we're going to start with y equals, and we're going to figure out what a is, so leave a space for a, and we're going to do x plus 1 squared plus 5. Because you walk into this problem, if you understand vertex form, you already know that the only thing you really need from the graph is a. Alright, so this is where I'm going to show you how to think about this. Alright, let's try making some marks here to refer to. So if I draw a horizontal reference this way and a vertical reference this way, then that'll help me show you what I'm thinking here, okay? Remember that A is represented by how far I go to when I go to the right one, how far up I go. But since they counted by 5s here, this is a little tricky. So I'm going to focus on the 2 points they gave me. So from the vertex, which is at negative 1, I would count 1, 2, 3 steps to the right. So I went to the right 3. That's a 3. And not showing up very well. Alright, so that I'm going to the right 3. And then I'm going to figure out, when I leave 5 and go to negative 13, how far do I go? If I go down 5, I'm on the x-axis, 13 more, I'm at my point, so a total of 18 steps down. So I went down 18. Well, how can I use that? Well, the fact that I had to go to the right and down tells me that my a is negative. Okay? Well, I went to the right 3, and on the parent parabola, I would go to the right 3 and up 9. But here I went to the right 3 and down 18. And what do you multiply 9 by to get negative 18 but negative 2? So that's the graphical interpretation. And if that's really good for you, then you can do some similar to the way we described on the last problem what the changes are from the parent graph, you could use that as your explanation here. I'm comfortable with either. Both would probably get you bonus points on a test. And that's the end